Here we're going to take a look at the Sanotronics simulation in Chapter 16 of our book. We're going to break the problem into the 4 parts that they did in the book. First, we'll create a static model, which gives us one model. Then we'll develop a probability section and generate random values given properties of the values. Then in part 3, we'll set up a data table and replicate our model for 1,000 trials. Then finally in part 4, we'll generate summary statistics and create a histogram to evaluate our findings. So the first thing that we need to do here is enter in the parameters that they have given us for the base case. So with the base case, they tell us that the selling price is $249 per unit. They also give us a fixed cost for admin and advertising of $1 million. So once I've entered that in, you can see that it's not very easy to read. But if you go up into your toolbar section and you click on this comma, it'll add in the commas for every thousandths place and make this easier to read. Since we're dealing with such a large number and it is a fixed cost whole number, we can go ahead and decrease the decimals and just show our $1 million. The next parameter that we're given for our base case is a direct labor cost of $45. Parts cost per unit, we are told, is $90. And then the demand for the base case is $15,000. Again, this $15,000 isn't formatted. One thing we can do to copy our format from our admin and advertising cost is go ahead and click up on that cell, then click the paintbrush for the format painter. And then we can go click in our new cell, the 15,000, and we copy down the format that we had with the 1 million. Just another way to do things. The format painter can make things very quick and easy. So again, these were the parameters for the base case. This will help us create just this one static model right here for the profit. This section is very handy because you can change these labor costs or parts cost per unit and the demand, and it'll modify your model and you can come up with best case scenario, worst case scenario as well. So we're just going to go ahead and calculate the profit right here. We're going to use the equation 16.2 from the book, but the profit model is going to be our price minus our cost times our demand, then minus our fixed cost, admin and advertising costs. So again, equals our price, what we're selling it for, less our direct labor cost per unit, less our parts cost per unit, multiplied by our demand, and minus our admin and advertising cost. Once we do that, we can see it's $710,000. If the format does not look the same as you have for admin and advertising costs or demand, go ahead and paint that down there or add in the commas, make it look the same way. So now we're going to go ahead and we're going to create a model, and we need to know about the costs and the demand. We're told that the direct labor costs follow a discrete probability distribution. The different types of probability distribution dictate in Excel how we find a random variable. They dictate the logic that we need to use. So it's very important that we pay attention to what kind of distribution that we have. So first we want to set up a table with the information from the book. So we're going to go ahead and fill in this cost per unit column as well as the probability column. Okay, so cost per unit range from $43 to $47. And then we're given the associated probabilities of 0.1, 0.2, 0.4, 0.2, and 0.1. And we need to create a discrete probability distribution for Excel to randomly select these costs in our model. So what we do with these two lower bound and upper bound columns is we need to create values that go from 0 to 1. The way that Excel works is that it randomly picks a number between 0 and 1 and then finds our random variable based upon that. So our first lower bound is going to be 0. And our upper bounds are built off of our lower bounds. So our first upper bound equals the lower bound that we have on the left here plus the probability, or 0.1. So our next upper bound, or excuse me, our next lower bound equals our previous upper bound. And this upper bound equals the lower bound plus the probability. So now we can go ahead and copy these down. We can see that we go from 0 to 1. So again, to say what I said a moment ago, Excel finds a random number between 0 and 1. So if Excel spits out 0.5, what it's going to do is it's going to look at this table. 0.5 falls in this range right here. So we would take a cost per unit of $45. If it spit out 0.2, then 0.2 is associated with a cost per unit of $44. So that's how that works. And we know we've done it right because we go from 0 to 1. Now, given the parts cost information, and we know that it falls, given the parts cost information, so now we're up here, we're told it follows a uniform distribution, and we want to take and enter the lower bound and the upper bound that we're given. So the lower bound was 80, the upper bound is 100. From there, we know that a characteristic for a continuous probability distribution is that the cost can take on any value between the lower and upper bound, meaning that any number of decimals can exist and any value in there is possible with equal likelihood. Okay. So then, given the demand information right here, we're told that this follows a normal probability distribution with a mean of 15,000. Go ahead and enter that mean, and a standard deviation of 4,500. Again, we can copy or we can paint in our format. So go select the format from the 1 million and paint it in here with our mean and standard deviation. Okay. So now we have all the information that we need to create the random values that are going to be used in our model. So we can scroll down here into our model and start to set this up. We need to set up our data table, and we want to run 1,000 simulations. So we start with simulation trial 1. We know we want to go all the way down to 1,000. So the easiest way to do this is click on the 1, then go up to your toolbar here, and we want to click fill. Fill for me is just this down arrow icon. It might say fill on your screen. Then we go down to series. We want to fill in the column by a step value of 1, meaning that we're counting by ones, and we have a stop value of 1,000. Click OK. Now to see if we've gone all the way down to 1,000, you can simply double click on the bottom line of the 1, and it pops you all the way down to the bottom row or 1,000. To get back to the top, double click on the top line. Okay, now we're ready to enter our direct labor costs, and again we know they follow a discrete probability distribution. So we'll use a random number generator, and it is called VLOOKUP, or value lookup is what it stands for. So direct labor cost per unit, again, equals VLOOKUP, parenthesis, here we enter our random variable, or RAND, and a full set of parentheses, comma, now we need our table. So we want from the lower bound all the way to the cost per unit. So this entire table is what we're going off of. Go ahead and lock that in so that we can copy our formulas down in a little bit. And comma, now we're looking for the column index number. We know that our direct labor cost per unit needs to be this one of these values here in our cost per unit column, and that's our first, second, third column. So our column index number is 3. Then the next comma, we're going to go ahead and enter true so that this finds an approximate match. Here we can see right now I have 46. Now every time I make a change, it's going to give me a different random number in here. Your table is going to look different than my table. Then we can move on over to the parts cost per unit, and we know this follows a uniform distribution. It's equation 16.3 in our book, and we have a lower bound of 80 and an upper bound of 100. So our equation here is going to be equals our lower bound, absolute, plus our upper bound, again absolute, minus our lower bound, absolute, multiplied by a random number. Okay. So what this equation does is it takes our lower bound 80, and then when we add in the difference multiplied by some random number, remember the random numbers between 0 and 1, we're effectively adding in a portion of the $20. So you can see in our example now, we've got a direct labor cost of 45, parts cost per unit of 93.45. Now we'll go ahead and move over to the demand, which follows a normal distribution. And here we're going to use our norm.inverse function. So equals norm.inv, parentheses, our probability is our random variable. So RAND, then full set of parentheses, comma, our mean, lock your mean in, comma, your standard deviation, again, lock that in, and end parentheses. So this gives us a randomly generated value that's normally distributed around the mean of 15,000 with a standard deviation of 4,500. So again, you can see that everything else has changed because I made yet another change. So now it's time to enter in our profit. Profit's going to be very similar to what we had before, but now we're using these new randomly generated costs per unit and demand. So here our profit equals the selling price. So go back up and get that. That doesn't change. Make that absolute. So selling price minus this labor cost minus our random parts cost per unit multiplied by our random demand minus our fixed admin and advertising cost. And that again can be absolute. Okay, so we can see here we have a profit of just over 1 million for this particular simulation. So then we want to go ahead and do this for all 1,000 trials. So we can copy these cells down. If you go ahead and click on the ones you want to copy, then go over to your little box on the right. If you double click that, it will copy it all the way down to the bottom. Okay. Now we want to use what's called the what if function or what if analysis built into Excel. So this time we want to highlight our entire table, but we also want to include the simulation trial column. So if you go ahead and you click on the first row, hold down Shift and double click on your bottom line there, it's going to highlight the entire table. So do that, then go up to the Data tab, click there, you can see What If Analysis, click on it, go down to Data Table, then we want to click on this column input cell and go up to the top and click on D1, okay, click OK. Now nothing happened or we don't see anything in this cell D1, but what it does is it forces Excel to regenerate the simulation, to rerun the simulation each time a change is made. So we're going to go ahead and stop this video here, and in part 2, we're going to do the profit summary statistics as well as build the histogram.